So the next thing that we're going to do is that we have the equation of minus x, or the absolute value of minus x is equals to the absolute value of x. Now we are going to split that, and we're going to prove that, or we're going to bring one of this side to the other side. And how do we do that? We're going to refer to, or we're going to say, this is the left hand side and this is the right hand side. This refers to the right hand side, this refers to the left hand side. So the left hand side can be written as left hand side is equals to the absolute value of minus x. So our point of segregating this equation into two hands is because we want to bring either of them. We want to take one hand and we want to transform that into the other hand. So if we consider this to be the left hand side, we want to bring that, or we want to prove that we can bring this absolute value of negative x into the right hand value, which is the absolute value of positive x, or simply x. We just don't write that positive number. So let's also include include the right hand side so that it becomes clear for us. So the right hand side contains the absolute value of x. Now we are going to transform this left hand side so that we can prove this equation. We're going to transform this minus x, the absolute value of minus x, into this absolute value of x. And how do we do that? We are first going to say that this is minus x, or let's consider this entire thing to be x. So when we take off these bars, which you can see, the right hand bar and the left hand bar, it becomes x. Then when we place that again, or placing the opposite value of minus x, then it becomes the positive value. So how do we do that? So the first thing that we have done in here is that we have taken off these bars. Now what we are going to do is we're going to place the opposite value, which we consider to be minus x, placing the opposite value, of minus x. Let me scroll down. So if we place the opposite value inside this x, what we get is something like this. So we have taken off the bars, or we have taken off the enclosing bars from this absolute value of x, and we have made it minus x. So this x can be replaced with the opposite value right now. So if we replace this opposite value, so it becomes, or the negation of minus x, which is that's the way we say that, or you can simply say that negative or minus into minus makes it positive x. So we can currently so we can currently say that this is x, and we can also say that the positive, or the absolute value of x, we can apply back those bars once we get the answer. So just as I've shown you that if we have x equals to 4, we can say that the absolute value of 4 is also 4, or we can write the same thing as the value of 4 can be written as the absolute value of 4. So this is the same thing, just like as we have done in here. So we can therefore write this to be x So I've just rewritten this stuff. This entire thing is the similar thing. So we now can see that we have arrived at the right hand notation. So therefore therefore we can write that LHS, or left hand side, is equivalent to the right hand side. So hence we can say that the absolute value of minus x is actually equals to the absolute value of x. Now we have seen two steps. There are currently, as I have actually devised three steps. So the last and the third step is taking the value of x less than 0 when x is negative. So let's have a look. So the third part is when x is negative, or we can write this as x is negative. Let me close the bracket, and like before, let me get down. So like before, let me draw a number line so that it becomes easier when we try to represent our values graphically. So this will be the number line with the origin of 0. So you must remember those three steps. So first draw the number line with and set this 0 or the origin, then determine which side will be positive, and conventionally the right hand side is always considered to be the positive side that contains the positive coordinates. And next is we are going to assume, because we have now considered that x will be negative or x will be less than 0, hence we can say that x is moving on the left hand side, because this side, the left hand side, is considered to be negative, or it contains all the negative coordinates. So like before, we can consider something like, let the opposite value be denoted as minus x. Now it should be greater than 0. So I guess it might be a little confusing at the very first moment. So previously what we have seen is that we have considered something like so we have considered to be something like this: minus x is less than 0. So because similarly in here, previously it was when x is positive, but right now this is when x is negative. Our value of x, or the coordinates, will be negative. Previously we dealt with the positive coordinates that are residing on the right hand side, but right now this was the previous one. So right now we are going to deal with the values that are residing on the left hand side, or the coordinates that are negative. So this is the current one, or we are going to deal with the left hand portion of the number line. So that's why we have defined that x is less than 0. So you can also write this as positive x is less than 0. Now let me draw another number line and let me make this thing clear, because you might be considering this to be minus x less than 0, but that's not the case. Let me draw another number line. Let me set the origin, and this side will be positive. Now what happens if we try to apply minus 2 in here, and this is minus 1? Now I'm telling you that x is equals to minus 2, and you can also write this as something like minus x equals to 2. So what this necessarily means is that you will have to, with this minus x, we are meant to move on the left hand side of the number line. That's why I have shown that we are moving on the left hand side of the number line, or at any given point our x